Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to make the ball actually bounce around the screen. And it's not going to be perfect by the time we finish this tutorial, because we've still got to consider stuff like the difference between the size of the bitmap and the size of the ball, because I've actually got a bitmap here that's bigger than the ball, which actually I could have fixed, but I'm going to kind of fix that later using a technique that you might find useful. But let's just get it moving for the moment, because that's going to be a little bit exciting. So I'm going to right click my package here and go to new class, and let's have a class called ball, and I'll click finish, and I'm going to say ball extends sprite, and do Ctrl+Shift+O to add the input for sprite there. Let's see what's wrong with this, and I need to add a constructor here, so I'll add that, which just calls the superclass constructor, and the sprite class is this one I've defined in the last tutorial here. Now for the ball's going to need some update code, so I'm just going to cut this method out of here, because I think that in general I'm not going to force my sprites to have an update method. Like, I could make this an abstract class and give it an abstract update method, but I think not every sprite is going to need to update itself, as we'll see. So I'll paste that into ball, which is going to need an update method. And in update now I just need to do stuff to change the location of the ball, basically. And let's go to game, and that's where I'm using this sprite class, but I'm going to change this to the ball class to use that instead of sprite. And now I'm going to give this ball a private float x speed, or maybe I'll call it speed x, and a private float speed y. And in fact I'm going to just hard code these, because I think I'm not going to change these. Let's say private final float speed x, and let's try 0.5 and see how that goes, and private final float speed y equals 0.5. and in case you didn't guess, this is going to be the speed in the x direction, and this is going to be the speed in the y direction, or the vertical speed. And I need to put f there because it's a float on the end of that number. And I'm also going to give it a private int direction. Let's well, x dir, let's say, or direction x. Yeah, direction x. And I'll set that equal to maybe 1, and private int direction y equals 1. And this is going to be, of course, the direction that it's heading in x or y, and I'm going to use these to control the bounce of the ball, basically. And now to calculate the new position of the ball, I'm going to say, well, I want to access x and y, but in the sprite superclass here, x and y are private, so I can't access them even in child classes. And rather than expose them to child classes, which makes the child class very dependent on the precise implementation in the parent class, rather than do that, I'm just going to right click here and go to source, generate getters and setters, and I'm just going to generate getters and setters for them. And then, as long as the getters and setters don't change, I could happily get rid of these if I wanted and replace them with something else. So in update I want to say float x equals get x, and float y equals get y. And then I want to do something to them, like x equals direction x times speed x. And actually I don't want to say equals, I want to say plus equals. So we're going to add to x the the direction times the speed, and I'm also going to multiply there by the elapsed. So this is just going to be plus or minus 1 direction, and speed obviously controls how fast it goes, and we need to make the distance that it moves, the distance that we add to x, proportional to the elapsed time, which is in milliseconds. So I'm multiplying by elapsed, so that if we have a long period between since update was called last, then it's going to move a correspondingly long distance. It's going to be the same for y, so I'm going to say y plus equals direction y times speed y times elapsed, and then finally we can say set x and set y y. Now in between here I'm going to need some code that stops it flying off the edge of the screen, but let's just run it now and see how it looks. So I'm looking at my phone, and for some reason the list of numbers is showing, which I don't want to expose to public scrutiny, but if I can just get rid of that. And yeah, here's how it looks now. And whoops, where are we going? So it's static at the moment, and the reason for that is that I forgot to call update. So I'm going to go into a game now, and now in here I'm going to say ball.update elapsed. I'm going to run this, and let's go back to my game here, and if we're lucky we're going to see a moving ball in just a second. And actually I could make it bounce around the screen, but maybe I should save that for a future tutorial. Well, let's see how this goes. And here we go. There's no sign of the ball at all. I don't know why not. Well, hopefully we've initialized the sprite, so the sprite's been initialized with quite reasonable values, and it may be that the values that I'm setting for x and y, well, they must be off the edge of the screen, and it may be that speed x and speed y are simply much too great. Let's just put the log d in here and say x is plus x, and what I'll do to give it a fighting chance is I'll put 0 in here, and I'll run that, and I have to add the import for log.d, and I'll run this. So finally my ball is on the screen, and it's moving in crazy leaps towards the edge, which isn't quite what I expected. I'm not really sure why it's so lacking in smoothness, and that's something that I'll have to look into, but I think we'll leave it there for now, and in the next tutorial we'll look at actually making the ball bounce off the edges of the screen. And I think I have a little problem with my phone or something at the moment, because there's no reason I can see why this animation shouldn't be smoother, and I think the code is fine, and I hope to demonstrate it working very nicely in the next tutorial. Okay, so that's it for this time, and until next time, happy coding.